Hey guys, we're gonna go over the section 1 review. Okay, so let's start from the top. Number 1. Okay, this number here is just the section and topic for this question. So this is topic 1, section 1, topic 1. This is section 1, topic 3, and so on and so forth. So if you are struggling with that particular question, you can look at the notes or the homework from that lesson. Maybe take a look at the videos on the course website and that sort of thing to try to help you out. Okay. So g of x plus k of x. So I'm adding g of x, which is negative 2x cubed minus 9x squared plus 2x minus 4, and k of x, which is x squared minus 5x minus 1. So let's combine like terms. X cubed I can't combine with anything. I will be able to combine not negative 9x squared and x squared. I will also be able to combine 2x squared and negative 5x, and I'll be able to combine negative 4 and negative 1. So let's combine them. The negative 2x cubed we can't combine with anything, so I'll just write it down. Negative 9 plus 1 is negative 8, and that's x squared. 2 minus 5 is negative 3x. Negative 5 minus 1 is negative 4 minus 1 is negative 5. And that's our result. Okay, moving on to number 5. So here we are doing f minus k of x. So that just means f of x minus k of x. So the input for both f and k is x. That's all that means. I'm writing f again. Okay. Okay. So f of x is x to the 4th power plus 2x squared minus 3x minus 1. And k of x is x squared minus 5x minus 1. Remember to put the second one in parentheses because we do need to distribute that negative. So we're going to end up with x to the power of 4 plus 2x squared minus 3x minus 1 minus x squared plus 5x plus 1. So let's see what we can combine. We can't combine x to the power of 4 with anything. Ooh, that's crazy. I didn't mean to do any of that. Let me undo. I can't combine with anything, but I will be able to combine x squared with x squared. I'll also be able to combine x with x, and I'll be able to combine constant with constant. So we end up with x to the power of 4. 2 minus 1 is positive 1, and that's x squared. Negative 3 plus 5 is positive 2, and that's x. And negative 1 plus 1 cancels. So this is our final answer. Okay. Moving on to number 2. So now we are dividing f divided by k. So we are taking f, which is this function right here, and dividing it by k, which is this function right here. Now remember, the divisor, right, if it has a coefficient of 1 and a power of 1, we can do synthetic. But if it is not, then we have to do long division. So if you look at the divisor, right, we have 1x to the power of 2. So you won't be able to do synthetic on this one. We will have to do long division. So we have x to the power of 4. And then remember that when you are dividing, you do need to have any zeros for placeholders from the numerator, okay? So if you look at the numerator here, I do need to add a 0x cubed so that I could have that 0 placeholder for the missing x cubed term. Okay, and then the divisor is x squared minus 5x minus 1. Okay, so let's divide. I would multiply x squared by x squared to get x to the power of 4. So now let's multiply. X squared times x squared is x to the power of 4, which is exactly what I wanted. X squared times negative 5x is negative 5x cubed. X squared times negative 1 is negative x squared. So now let's subtract. And remember, when you subtract, you have to distribute that negative. Anything minus itself is nothing. 0 minus negative 5 is positive 5x cubed. 2 minus negative 1 is 2 plus 1, which is positive 3x squared. Remember, a double negative is a positive, right? And now we can go ahead and bring down the negative 3x. Okay, x squared multiplied by 5x would give me 5x cubed. So 5x times x squared is that 5x cubed that I wanted. 5x times negative 5x is negative 25x squared. And 5x times negative 1 is negative 5x. We can go ahead and subtract these two. So 3 minus negative 25 is positive 28x squared. Negative 3 minus negative 5 is positive 2x. And then let's go ahead and bring down that last term. Okay. X squared multiplied by 28 would give me 28x squared. And then now let's multiply. 28 times x squared is that 28x squared that I wanted. 28 times negative 5. Let me do this here on the side. 28 times 5. That's 40. And then 2 times 5 is 10 plus 4 is 14. So that's 140. So that is a negative 140 since I did a positive times a negative. And then 28 times negative 1 is negative 28. So now let's go ahead and subtract these two. Anything minus itself cancels. 2 minus negative 140 is positive 142x. And negative 1 minus negative 28 is negative 1 plus 28, which is positive 27. So this is my remainder. So this equals x squared plus 5x plus 28 plus the remainder, which is 142x plus 27, over the divisor that I divided by, which was x squared minus 5x minus 1. I'm just going to go ahead and move this over because it doesn't look right. There we go. So that is my quotient, my result. Okay. Now let's do g of x divided by k of x. So the divisor is still the same, which this divisor does not meet the criteria for doing synthetic division. So we have to do long division, but now we're doing long division and the numerator is g of x. So we are dividing negative 2x cubed minus 9x squared plus 2x minus 4. So notice that there is no 0 there. So we do not need to have a placeholder, okay? All right. So let's go ahead and start with the division. So x squared multiplied by negative 2x would give me negative 2x times x squared will give me negative 2x cubed, which is what I wanted. Negative 2x times negative 5x is positive 10x squared. And negative 2x times negative 1 is positive 2x. Let's go ahead and subtract these two. Anything minus itself cancels. Negative 9 minus 10 would be negative 19x squared. And then 2 minus 2 cancels. So this is 0x. I'm just going to put 0x to hold that place there so that I remember that it is nothing. And then I'm going to bring down the negative 4. So x squared multiplied by negative 19 would give me negative 19x squared. Negative 19 times negative 5. 19 times 5, let's see, 5 times 9 is 45. And then 5 times 1 is 5 plus 4 is 9. So this is 95. So negative times a negative is a positive, so that would be 95x. And then negative 19 times negative 1 is positive 19. And then let's go ahead and subtract these two. Anything minus itself is nothing. 0 minus 95 would be negative 95. Negative 4 minus 19 is negative 23. Oh, and I forgot my x here. Negative 95x. Almost forgot that. So my final answer, g of x divided by k of x, or I could write this as g divided by k of x, equals negative 2x minus 19 plus negative 95x minus 23 over my divisor, which was x squared minus 5x minus 1. Now, one thing that you can do that I will show you, if you notice, both of the terms in the numerator are negative. And usually what we do when there is a negative on the front term is to factor out a negative, which factoring means dividing, okay? So you could divide a negative into the numerator and bring that out to the front. So I could bring out a negative and write this as minus if I bring it out from here. So if I divide negative 95 by a negative, that would be positive 95x, and then divide negative 23 by a negative, that would be a positive 23. And I don't have to divide the denominator because I accounted for that by putting the minus here, okay? So I'm just factoring it out and bringing it to the front, making that an equivalent fraction. If I were to take this negative and distribute it to the numerator again, I would get the original. So on the test, right, you have answer choices, multiple choice on some questions. So if you see it like this, you should be able to recognize that that is the correct answer and not this one, okay? All right. Or, well, not, let me go back. Not necessarily that it's not this one, but that if you don't see this one and you see something like, for example, negative 95x plus 23, then you should know that these two are equivalent, is what I'm trying to say. Okay. Moving right along, let's take a look at number 3. Okay, so k of x times h of x. So I'm multiplying k and h. So k is x squared minus 5x minus 1. H is x minus 4. Let's go ahead and distribute. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. Negative 5x times x is negative 5x squared. Negative 5x times negative 4 is positive 20x. Negative 1 times x is negative 1x. And negative 1 times negative 4 is positive 4. Now we just go ahead and combine like terms. So we can combine x squared with x squared. We can combine x with x. So we get x cubed. Negative 4 minus 5 is negative 9, x squared. 20 minus 1 is 19x. And 4, of course, is just 4. Okay, let's take a look at number 7. Ooh, on this one we have f of x minus 3 times, and then notice in a grouping symbol, h plus g, okay? So we are going to do h plus g first because that is in parentheses. Remember, you have to follow the order of operations, right? So we're going to need to add h plus g first. So here's h and here's g. And we also need f. So here's f. So let's write it all out. X to the 4th power plus 2x squared minus 3x minus 1. And then minus 3 times h, which is x minus 4, plus g, which is negative 2x cubed minus 9x squared plus 2x minus 4. Now again, because that is in parentheses, we need to add these first. So let's simplify that addition. So I'm just going to bring down the other things right now. Okay, so negative 2x cubed will go first. Remember, you want to keep it in standard form, so highest exponent to lowest. Negative 9x squared will go next. I can't combine that with anything else. Now, x plus 2x I can combine. X plus 2x is 3x. And negative 4 minus 4 is negative 8. I've used all my terms. Now I can go ahead and multiply in the negative 3. So I'm going to, again, bring down my front term. And then I can distribute the negative 3. Negative 3 times negative 2 is positive 6x cubed. Negative 3 times negative 9 is positive 27x squared. Negative 3 times times positive 3 is negative 9x. And then negative 3 times negative 8 would be positive 24. Okay, last step is just combine whatever I can. So x to the power of 4, I can't combine with anything. X to the power of 3, I can't combine with anything. 2 plus 27 is 29, so I can combine those two. Negative 3 minus 9 is negative 12. And negative 1 plus 24 is 23. Okay. Let's move on to number 4. On number 4, you're finding f of 2. Okay, so I'm just inputting 2 into my function f. Here's f. So f of 2 equals inputs to the power of 4 plus 2 times the input squared minus 3 times the input minus 1. Okay. Exponents first, right? So I need to do this exponent and this exponent first. So 2 to the power of 4 is 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4, 16. 2 squared is 2 copies of 2, which is 4. And I'm just going to bring the rest of this down. Okay, now we can do multiplication. So now I can multiply 2 times 4 and negative 3 times 2. So we end up with 16 plus 8 minus 6 minus 1. And now we can do addition and subtraction from left to right. 16 plus 8 is 24. And then 24 minus 6 is 18. And 18 minus 1 is 17. All right. Last one, number 8. G divided by h of x. So remember, that's just g of x divided by h of x. So I'm taking g and I'm dividing h. Now, the divisor is h. And notice that h is in the format x minus c. So that fits the criteria, coefficient of 1 and power of 1 for the variable, and then just a constant. So we can do synthetic division on this one. So remember, c is the opposite of what you see because it's minus c, so you change the sign, right? So I see minus 4, so that's actually plus positive 4. And then for my numerator, I just need the coefficients. Now, if there was any missing terms, I do need to put a 0 for a placeholder, but I don't have that here. So my coefficients are negative 2, negative 9, 2, and negative 4. Bring down your first term, then you multiply 4 times negative 2. Right, that next door is negative 8, and then we add vertically. Negative 9 plus negative 8 is negative 17. Then we multiply 4 times negative 17, which I'll do here on the side. 4 times 7 is 28. 4 times 1 is 4, plus 2 is 6. So that's negative 68. And then we add vertically, so that's negative 66. And then negative 66 times 4, again, I'll do this math on the side. 66 times 4, 4 times 6 is 24. 4 times 6 is 24, plus 2 is 26. 264, right? We did negative 66 by positive 44. I'm sorry, by positive 4. So that is a negative 264. So negative 4 plus negative 264 is negative 268. So our result, remember, when we are doing synthetic division, that is only allowed to be done when your coefficient is 1 and your power is 1. So you're always doing synthetic division when you're dividing by 1 copy of x. And if you're dividing by 1 copy of x, that means that the result will always be 1 copy of x less than what you started with. So if you started with this and you divided by 1 copy of x, your new result will start at x to the power of 2. So this is negative 2x to the power of 2 minus 17x minus 66. And then minus, you could do 268 over the original divisor, which is x minus 4. Or you could also write it as plus a negative, right? So remember, you could always distribute that negative if you want. Okay, let's keep it moving. So number 9 says use the graph to answer the following questions. Okay. For the intervals, you're going to write both a set builder and interval notation. So what is f of 3? So if the input is 3 into, this is our function f, the input is 3. Let's find that point on the graph, right? X value of 3 is here. So that point is 3, 1. So the output is 1. For the value, what value of x is the y value, is f of x equal to -1. So I'm looking for the input where an output is -1. So, okay, a y value of -1 is here, right? So if I follow that over to the graph, here's that point. So the y value of -1 has what input? Well, x value of 1. Okay. Part C, what x value gives you a y value of 2.5? So 2.5 y value is right here, and actually the point is right there on the graph. So this y value of 2.5 has what x value? 0. Okay. And then the last parts are what are the domain and the range. So domain, x value, smallest x value is found on the left of the graph. Now that is an arrow. So the smallest is -infinity. And then to the highest, the biggest x value on the right-hand side, that is also an arrow. So that's going to +infinity. In set builder, you could just say x such that x is an element of all real numbers. If you don't want to be that fancy, you could just say all real numbers on the inside like this, or something like that. But this is the fancy way to write it. X such that x is an element of all real numbers. Okay, what about the range? So the y value, right? The smallest y value is always found on the bottom of the graph. So is there a bottommost point? Yeah. Here's that bottommost point right here. So what is that y value? That y value is -1. That is a solid line, right? So that is included. -1. All the way up to what's the highest point? Well, we have arrows at the top, right? So that's going up to +infinity. In set builder notation, that would be y such that the y value is bigger than or equal to -1, right? Anything from -1 and bigger. Okay, moving on. Number 10. For all of these, I'm going to go ahead and write the domain and range, and we are writing both ways. So let's start with the domain on all of them. Okay, I'm going to write the domain on all of them on top. So the domain for this one, right, I cannot write in interval notation because it is not an interval. They are just points. This point, this point, this point, this point, and this point. So what are the x values, right? We have -3, -2, 1, and 4. Okay, the domain for this one, I can write as an interval because it is a continuous line, right? It's not just this point, this point. So the smallest x value is right here, which is -3, till the largest x value, which is right here, which is +3. Okay, and I can write that in interval notation. If I want to write it in set builder, I would write x such that -3 is less than or equal to x is less than or equal to 3. And that just means that x is between -3 and 3. Moving right along to part C, right? Our smallest x value, here's that point. Now, do you notice that is an open circle? So that is -4, but it is not included. So parentheses all the way to rightmost point. Oh, there's an arrow. So till infinity. As set builder notation, that would be x such that x is greater than -4. No or equal to because we are not including -4. Okay, moving on to this one. Our x value is 1. That's the smallest one that we start with, but it is not included. And then all the way to the right, we also have arrows here on the right. So that is going to +infinity. So this is x such that x is greater than 1. Okay. Let's move on to the range. Okay, so the range on the bottom. Again, for this one, I cannot write it in interval because there is no interval. It's just points, right? So starting from the lowest points, we have -4. Then our next point is this one, which has a y value of -2. Then our next one is this one, which has a y value of 0. Then we have this one, which has a y value of 3. And then lastly, this one, which has a y value of 5. Okay. Moving on to the next one. We do have a continuous line here, so I can write an interval. The smallest y value found on the graph would be right here, which is a y value of -4. And that goes all the way up to this y value up here, which is +3. In set builder notation, that would be y such that y is between -4 and 3. Moving right along to this one, what is the lowest point on the graph? Well, right here, that has a y value of 1, and that is solid, so included. And then all the way up, highest point, here I have a point, but look at this arrow, right? That means that it's going to continue past that. So it is going to go up, the y value will get higher and higher till infinity. So y value such that y is greater than or equal to 1. And then the last graph here. So if you look at the bottom, right, we do have an arrow at the bottom and an arrow at the top. But this one's a little tricky. Look at the middle of the graph, right? Do you see that open circle there? So a y value of 2, is that found on the graph? Well, no, because that is an open circle. Now, if there was a point here as well, then that y value of 2 would be found. But there is no point. If I try to find a y value of 2 on the graph, there is no y value of 2. So that means that our function does go from -infinity to +infinity, but there is a break at 2. You cannot include 2. So you say -infinity to 2, not including 2, and 2, not including 2 to infinity. That's how you say everything except 2. Now in set builder, you could write this as y such that y is greater than 2 or y is less than 2. You wouldn't want to include 2. Okay, so everything bigger than 2 all the way to infinity, everything smaller than 2 all the way to -infinity. You could also like rearrange this and write this as y is less than 2 first, and then y is greater than 2 after. Okay, let's move on. So what is the value of f of 1? So here's our function f. Input of 1 has an output of 5. For the next one, we have asking us for the input. What is the x value when the y value equals 2? So if an output of 2, y value of 2, what is the input? What is the x value? Well, -1. Okay, let's move on to number 12. So number 12, we have part A. Now, it's kind of hard to see this graph, so I apologize for that, but this is y equals f of x, and this is y equals g of x. So this is the f of x function, this is the g of x function. Here, we're doing f divided by g of 6. So f of 6 divided by g of 6. Okay, well, what is f of 6? Input 6, right? Follow that up to the graph is right here. That y value is 2. What's g of 6? G of 6, here's 6 on the function g. Follow that up to the graph. Here's the point. Y value of 1. 2 divided by 1 is 2. Okay, part B. G of 2 plus f of 2. Okay, g of 2, here's g. G of 2, follow that up to the graph right here. So that y value is 3. And then f of 2, right? 2 input for f, x value. Here's that point, that y value is 2. What's 3 plus 2? 5. Okay. All right, let's move on to number 13. So we're adding here, and we do have some fractions, okay? So what can we combine? We can combine a cubed with a cubed. we can combine A with A, and we can combine constant with constant, okay? Number without variable, number without variable. Okay, so let's start with the first term, would be a to the power 4. You can't combine that with anything. You do want to write it in standard form. Then let's move on to a cubed. Now, in order to add fractions, I do need to have a common denominator. So I'm going to change this to 2 over 1. And the denominator does have to be the same. So I'm going to multiply this fraction by 8. 2 times 8 is 16. 1 times 8 is 8. I have 16 over 8. 16 minus 15 is 1. And the denominator stays. Then we can move on to a, which is the next power, right? 7 over 1, I need the denominator to be the same, so I'm going to multiply this by 3. 7 times 3 is 21. 1 times 3 is 3. 11 plus 21 is 32, and the denominator stays. And then lastly, 1/2 minus 3 over 2. The denominator is already the same, so 1 minus 3 is -2, and the denominator stays. Now, last step is to make sure, can you simplify, right? Now, 32 over 3, you can't simplify, but you can simplify -2 over 2. -2 over 2 is -1. Always have all of your answers in simplest form, right? All right, let's move on to 14. Okay, for 14, we're finding the product. Now remember, multiplying fractions is different from adding fractions. To multiply fractions, all you do is multiply top times top over bottom times bottom. So 6 times 3 is 18. M times m squared is m cubed. 6 times 5/3, remember whole number times fraction, you multiply the numerator because the denominator is 1, so the denominator is going to stay the same. 6 times 5 is 30, and m times m is m squared. Okay, 6m times 6 would be 36m, and then now we can move on to the next term. 6/5 times 3, 3 times 6 is 18, and the denominator stays, and that is m squared. Then we have 6 times 5, which is 30, and then 5 times 3, which is 15, and then no variable here, so the variable is just m. And then lastly, 6/5 times 6. 6 times 6 is 36, and the denominator stays. Now, all we gotta do is combine like terms. So we can combine m squared with m squared, and we can combine m with m. Now, remember, adding and subtracting fractions, you do need a common denominator. So I'm going to bring down my 18m cubed. But now, when I go to combine my m squared, I have denominator 3 and 5. So I'm going to have to multiply both fractions so that the denominator is that least common multiple of the 3 and 5, which is 15. I'm going to multiply this by 5. 30 times 5. Well, 5 times 3 is 15, so that's 150. And then over here, I'm going to multiply this by 3. So 5 times 3 is, of course, 15. 18 times 3, I'm just going to do this here on the side. 8 times 3 is 24. And then 3 times 1 is 3, plus 1 is 5. So that's 54. Okay. Now that the denominator is the same, it stays the same for my result. And this is an m squared term. 150, positive 150 plus 54 is 204. Okay. Now we can move on to m. Now this is 36 over 1, right? I do need that denominator to be the same. So I'm going to multiply by 15. 36 times 15. I'll do on the side here. 6 times 5 is 30. 5 times 3 is 15, plus 1 is 18. Add a 0 for that place there. 6 times 1 is 6. 1 times 3 is 3. And then we add all together. We get 8 plus 6 is 14. And 1 plus 1 plus 3 is 5. So that's 540. And 1 times 15 is, of course, 15. So 540 plus 30 is 570, and the denominator stays the same, and our variable is m. And then lastly, I can bring down the 36 over 5. Now, remember, you cannot just leave it like this because you need to simplify, right? So we can go ahead and simplify 570 over 15. That actually simplifies to 38. And 36 over 5 can't simplify at all, so you just leave it like that. And 204 over 15 simplifies to 68 over 5. And that is m squared. And of course, 18m cubed would just be 18m cubed. So that is your result. Right? All right, let's move on to number 15. All right, so for number 15, right, we're just simplifying this. Now this is subtraction, so I do need to distribute that negative. So this would be negative 6xy minus 8y to the power of 2. So we have 7y squared minus 3xy plus 4xy squared minus 6xy minus 8y squared. Now remember, you can only combine things that are exactly alike. So I can't combine this xy squared with this xy. It would also have to be xy squared, right? However, I do have an xy here and an xy here, so I can combine those, okay? So remember, you want to start with your highest power. Ooh, I almost missed. I can also combine 7y squared with negative 8y squared. Okay. So remember, you want to start with your highest power, and you want to do this in alphabetical order. So you do want to start with 4xy to the power of 2, okay? But I mean, the terms don't matter that much. You know, if you write them out of order, is still, you know, the same answer. It's just that, you know, just make sure that if it's like multiple choice, for example, that you're able to tell what the coefficient for the term is, because negative 4xy squared is different than positive 4xy squared. So you have 4xy squared, and then negative 9xy, and then lastly negative y squared. Okay. So moving on to number 16, we are dividing here, and they are asking us what is the remainder. So notice that question is not divide, and then what is the result? The question is what is the remainder? And then is g a factor of f? Okay. So this is f of x is divided by g of x, so this is f of x, and this is g of x, because f of x is being divided by g of x. Okay, so I'm dividing. Now the coefficient is not 1. I could divide by 4, but then I'd get a fraction here. Okay, and if I divide by 4 here, I get a fraction. If I divide by 4 here, I get a fraction. So instead of having a bunch of fractions and dealing with that for synthetic, I'm just going to go with long division. Okay, now remember, you do need to have the terms in order. So when I write it, I'm going to write it as 4b cubed, then negative 10b squared, then negative 38b, and then negative 21. And I'm dividing that by 4b plus 2. Okay, so 4b multiplied by b squared will give me 4b cubed. And then b squared times 2 is positive 2b squared. And now I subtract. Anything minus itself is nothing. Negative 10 minus 2 is negative 12b squared. And now I can bring down my next term. Negative 38b. Okay, so 4b times what will give me negative 12b squared? Well, multiply by negative 3b. Negative 3b times 4b will be negative 12b squared. Negative 3b times 2 is negative 6b. And then I want to go ahead and subtract. Anything minus itself is nothing. Negative 38b minus negative 6b is really negative 38b plus 6b. So it'd be negative 32b. And then we bring down our last term and go through this one more time. So negative 32 times, 4 times what will give me negative 32? 4 times negative 8 is negative 32. And then negative 8 times 2 is negative 16. And then we subtract. Anything minus itself is nothing. Negative 21 minus a negative 16. So that's really negative 21 plus 16, which is negative 5. And that is our remainder. So what is our answer? Negative 5. Not only did they ask you for the remainder, but they also asked me, is it a factor, right? Now remember, in order for something to be a factor, it has to be divided into it evenly, no remainder. We got a remainder. So this is not a factor. G of x is not a factor of f of x. All right, let's move on to number 17. Okay. So for 17, we are evaluating this for f of negative 5. So I'm plugging in negative 5 into the function. So f of negative 5 would equal negative, plug in input, which is negative 5 squared plus 3 over the input, negative 5 plus 16. Okay, remember order of operations, very important. Exponent first. So that's negative 5 squared. Negative 5 squared is 25. So that's minus 25 plus 3 over negative 5 plus 16. Now, negative 25 plus 3 is negative 22. And negative 5 plus 16 is 11. Negative 22 over 11 is negative 2. That's 17. Let's move on to 18. On 18, we are evaluating as well. But in this case, instead of plugging in a number, we're plugging in the expression a minus 3. Okay, we're just replacing the input, right? So g of input equals input squared plus 7. So we're plugging in a minus 3. Now, a minus 3 squared, you cannot, because these are multiple terms, distribute the power. It's 2 copies of a minus 3 multiplied together. So let's distribute. A times a is a squared. A times negative 3 is negative 3a. Negative 3 times a is negative 3a. Negative 3 times negative 3 is positive 9. And then I can bring down the plus 7. Combine like terms, a squared can't be combined. Negative 3a minus 3a is negative 6a. And 9 plus 7 is 16. So that is my final result. This is g of a minus 3. All right. Number 19 at the bottom here. Find the domain and range of f and tell whether the function, or tell whether f is a function. So domain, these are just a series of points, so I can't use an interval. I have to use set builder. 4, 3, 0, negative 7. Range, my y values, 1, 3, 5. Now actually, let me edit the domain because I really should write it smallest to largest. So negative 7 will go first, then 0, then 3, then 4. Okay, and now, is it a function? Remember, this is a function as long as every input has only one output. And each input has only one output, so yes, this is a function. All right, let's move on to number 20. Okay, so divide the following rational expression using synthetic division. Okay, now look at that. I have a coefficient here, okay? So in order to do synthetic, I have to divide and simplify this fraction by dividing 2 on top and bottom. So let me simplify that fraction, divide 2 on top. 8 divided by 2 is 4. 12 divided by 2 is 6. Negative 4 divided by 2 is negative 2. And negative 6 divided by 2 is negative 3. 2 divided by 2 is 1. And negative 1 divided by 2 is negative 1/2. Okay, so now I have ready for synthetic coefficient of 1, power of 1. Okay, so let's go ahead and do synthetic. So C, remember, is the opposite of what you see. I see minus 1/2, so that is positive 1/2. And then my coefficients, 4, 6, negative 2, negative 3. Don't forget, you always want to be careful with zeros for placeholders. So if you have any missing terms, you need to fill those in. In this case, we don't, so we don't have to. Bring down the first one, multiply. 1/2 times 4 is 2. Add 6 plus 2 is 8. Then we multiply. 1/2 times 8 is 4. Add negative 2 plus 4 is 2. Multiply. 2 times 1/2 is 1. Add negative 3 plus 1 is negative 2. So our result, remember, we are dividing by 1 copy of x, so that result will always be 1 power less than what I started with, right? So we have 4 is the first coefficient, x to the power of 2, plus 8x plus 2, and then the remainder is negative 2. That is over the divisor. What did I divide by? Look at my coefficients. My coefficients are 4, 6, negative 2, negative 3. What did I divide by? I divided by x minus 1/2. Okay. Now this is a perfectly acceptable answer, but maybe multiple choice, right, might be different. So you have to be able to recognize equivalent fractions. Now on the test, it might be whole numbers only. So if I multiply this by 2, if I multiply this fraction by 2, right, then I would get, let me just write down the first few terms. Okay, then I would get 2 times 2, which is 4, and then 2 times x, which is 2x. 2 times negative 1/2 is negative 1. So this is another equivalent that is not writing, you know, a fraction within a fraction, which is usually, you won't find that on like SAT kind of tests or anything like that. You will only find whole numbers in a fraction, not fraction within a fraction. So you have to be able to find that equivalent fraction. Okay. All right, let's move on to 21. So for 21, we are finding f of g of negative 1. Okay. Now remember, with composition, you do need to find g of negative 1 first. And if you want to rewrite that as f of g of negative 1, so that you can see that you are plugging in the input into f is the output g of negative 1. So what is g of negative 1? Let's find that first. G of negative 1, here's my function g. So I'm plugging in input negative 1. So negative 2 times the input negative 1 cubed minus 9 times the input negative 1 squared plus 2 times the input negative 1 minus 4. Okay. So exponents first, right? So I need to do that first, that first. So negative 1 cubed is negative 1 times negative 1 times negative 1, which is negative 1. Negative 1 squared is negative 1 times negative 1, which is positive 1. And then I'm just going to bring down the rest of this. Okay, negative 2 times negative 1 is positive 2. Negative 9 times 1 is negative 9. 2 times negative 1 is negative 2. And I'm going to bring down the minus 4. 2 minus 9 is negative 7. Negative 7 minus 2 is negative 9. And negative 9 minus 4 is negative 13. Now you're not done. That's g of negative 1. I have to take that and input that into f. So f of g of negative 1, which g of negative 1 is negative 13, equals, now here's f. F is negative 3 times the input cubed plus 2 times the input minus 4. The input that we're putting in is negative 13. Now, negative 13 cubed is negative 13 times negative 13 times negative 13. I could do that by hand, but I'm just going to use my calculator quickly here, is negative 2197. And I'm going to bring the rest of this down. I'm going to cheat again. Instead of doing this by hand, let's go ahead and use our calculator. Negative 3 times negative 2197 is 6591. 2 times negative 13 is negative 26. And of course, you bring down the minus 4. 6591 minus 26 minus 4 is 6561. All right, let's move on to 23. Now, for 23, we are doing f of g, h of g of x. So f composed with h composed with g of x. So take g, plug it into h first. Okay, so h of g of x, h of input equals input plus 2. So I'm plugging in g is 5x. So h of g of x equals 5x plus 2. All right, now I have h of g of x. So I can replace h of g of x here, right? F of input equals input squared minus 3. Now, that input that I'm putting in is h of g of x, and h of g of x is 5x plus 2. Remember, you can't just distribute that power, okay? You have to actually multiply 2 copies of 5x plus 2 multiplied together. Okay, so 5x times 5x is 25x squared. 5x times 2 is 10x. 2 times 5x is 10x. 2 times 2 is 4. And I can bring down the minus 3. I can combine 10x plus 10x is 20x. 4 minus 3 is 1. So this is f of h of g of x. All right, let's move on to 24. I'm sorry, 22, because it's right under it. Okay, so for 22, we are doing k of h of x. So k input equals input squared minus 5 times the input minus 8. Now, what is the input? The input that we're plugging in is h. H is x minus 7. So we're plugging in x minus 7 into the input for k. So again, 2 copies of x minus 7 multiplied together, okay, would be x squared minus 7x minus 7x plus 49. And then we could distribute negative 5x plus 35, and then bring down the minus 8. And then we just go ahead and combine like terms. X squared can't be combined. Negative 7x minus 7x is negative 14x, minus 5x is negative 19x. 49 plus 35 minus 8 is 76. And that is k of h of x. All right, 24. For 24, we're finding f of g of x. So f input equals 3 times the input minus 8. Now, what is the input that we're plugging in? G. What is g? Well, g is right here. X squared minus 5. And then now we just simplify. Distribute 3. We get 3x squared minus 15. Negative 15 minus 8 is negative 23. So we get 3x squared minus 23. And that is f of g of x. All right, let's move on. Now 25 is a word problem. It says, suppose the function f of x represents the number of US dollars equivalent to x Chinese yuan, and the function g of y represents the number of Mexican pesos equivalent to y dollars. So the input here is US dollars, and the input here is Chinese yuan. Okay, now an image will help us understand this function, okay? The composition function has to be exact, where the output of one is the input of the other one. So the output of one function, and I'm just drawing a little function image here. You know, I'm not the best drawer in the world, so you'll have to excuse me. But remember, the output of this one has to be the input for this one. So they kind of have to match, right? So if you notice the output here, here's f of x. F of x input is the Chinese yuan. Output is the US dollars. For g of y, the input is the US dollars. Using the S for dollar sign. I need one more S, US dollars. And then the output is the number of Mexican pesos. So notice the output of F is the input of G. So this will be F of X and this will be G of Y. You're going to input the yuan, output US dollars for F of X. Those US dollars you'll input into G, and that will output pesos. Okay, so G of F of X is the function that would represent input yuan, output pesos. Okay, so G of F of X, and it's asking me to write the function, right? So I actually have to fill it in. So G of input equals 14.07 times the input. The input that we're plugging in is F, which is 0.15x. Now, I'm just going to use a calculator to be lazy here. 14.07 times 0.15 equals 2.1105x. So G of F of X equals 2.1105x. And this is the function that I can use. I can input any X value, and that will output pesos. I can input any yuan, and that will give me pesos. So find the Mexican pesos for an item that costs 15 yuan. Well, I can use my composition, right? I input yuan, I input 15 yuan, and that gives me 15 times 2.1105, which is 31.66 pesos. And I am rounding on that one. Oh, and I just realized for my notation, right, I forgot to put the F. So G of F of 15. There we go. All right. So these next questions are just a quick and easy, is it even, odd, or neither? Okay. Now on this, it doesn't tell me that I actually have to do these algebraically. Okay. Now if it says determine algebraically, then I need to do it algebraically. Or if the, you know, the example means that I can't do it in any other way. This first one, remember, there is a trick when there are just terms added together. If it's a polynomial, then you can look at the powers. If you have even and odd powers, and remember that a constant is x to the power of 0, which is considered even. So if you have a mix of even and odd, that means that it is neither. So I don't even have to do the work on this one algebraically. I know that it is neither. Now for part B, this is not a polynomial. This is not just terms added together, right? I have a fraction. If you have absolute value, if you have square root, any one of those things, you cannot use this trick for it. So let's find this algebraically. So remember, first plug in negative x. So 6 times negative x squared minus 3 over negative x to the power of 4. And then we're going to compare these two. I have to simplify it first. Negative x squared, 2 copies of any number would make it would still be positive, right? Negative times a negative is a positive. So this is 6x squared minus 3. And then in the denominator, negative x to the power of 4, that's 4 copies of a negative, which will be a positive as well. So now let's compare, is this equal to the original g of x? Yes, it is. So that means that this is even. Okay, remember with tables, you want to take a look at opposite numbers. -2, 2, -4, 4, right? And look at the outputs. If the y value is the same, right? If the output is the same for opposite x values, then that is even. Okay. Now looking at this next one, we have, again, we want to look at opposing numbers. So -1 and 1, we have 0 and -5. Then for -2 and 2, we have 5 and 7. So they are not the same and they are not opposites. So this is neither. They're not either matching. One is on this x value, right? Here's the y-axis. X values that are the same, but one is on the negative side and one is on the positive side. If it has the same y value, it's even because it has y-axis symmetry. But if it's like nothing at all, like this is over here 5, this is over here 7, then there's obviously no symmetry at all. So that's neither. Part C. Okay, now this is just terms added together, so I could use my trick. Odd, odd power. Both are odd powers, so this is odd. You could also find it algebraically, but you don't need to, right? You only need to find it algebraically when there is like a fraction or you know, fraction with variables or square root, absolute value, any funky things. As long as it's not terms added together, you have to, let me rephrase that. If it is terms added together, you could use the trick. If it's not, you can't, and you have to do it algebraically. All right, part D. Okay, let's look at opposing x values. So -1, 1, -2, 2. Okay, notice opposite inputs have opposite outputs, right? So if opposite inputs have opposite outputs, this is odd. Okay. And on this 2 graphs, let's go ahead and take a look. Remember, y-axis symmetry, right? If opposite inputs have the same y value, right? This is -1, -2. This is 1, -2. So opposite inputs have the same y value, then it has y-axis symmetry, and therefore it is even. Okay, now if you look at this one, it's double reflection, right? Reflect over y and reflect over x. If you look at opposite inputs, they have opposite outputs. So here, this is about like +1/3, and here this is about -1/3. So this point is -2, +1/3. This point would be +2, -1/3. So opposite inputs have opposite outputs. If opposite inputs have opposite outputs, it is odd. All right. So moving on to 27, okay, when introduced in 1997, a DVD player sold for about $500. In 2007, a DVD player could be purchased for $90. So find and interpret the average rate of change in price per year. Okay, so 1997, the price was $500. In 2007, price is $90. So what is the average rate of change? So we need to figure out what is the difference of the inputs and what is the difference of the outputs. Well, from 500 to 90, and I could just think about that is I'm subtracting 500 minus 410 would be 90. And then from 1997 to 2007, I would be adding years. That is 10 years later. So I'm adding 10. 1997 plus 10 is 2007. So the average rate of change, remember, the change of the Y value goes on top. The change of the output is the numerator, and the change of the input is the denominator. So negative 410 divided by 10 would be negative 41. And that's the average rate of change in price per year. So basically how you can interpret this, because this is a real world problem, right? The price of the DVD player, it's minus, right? So it decreased $41 per year on average. On average. Okay. All right. All right. Last two questions. So find the average rate of change given the function over the defined intervals. So here we are going to find the average rate of change between 0 and 2. So remember that this is the domain, okay? This is the X value. This is the input, okay? You're going from input 0 to input 2. So input 0 to input 2, you need to find the Y value. Now this is a table, so you could just look at the table. Input 0, output 5. Input 2, output negative 3. Now the average rate of change is just the change of the Y value over the change of the X value, right? So from 5 to negative 3, that is a change of minus 8. From 0 to 2, that is a change of positive 2. So our average rate of change here would be negative 8 over 2, which is negative 4. Okay. From a graph, right, you can do the same thing. Again, we are looking at an interval. Both of those from 1 to 3. Here's from 1 to 3, you're looking at the X value. Okay, so I'm trying to find what is the average rate of change if I just average that out. Okay, so you use a line to connect the two, like so. All right, it's not going to be exact, right? I'm not going along with that curve, but it's just the average. So input 1, input 3, what are the outputs, right? Input 1, output 0. Input 3, output negative 4. Okay, so from 0 to negative 4, that's a change of negative 4. From 1 to 3, that's a change of positive 2. Negative 4 divided by 2 is negative 2. You can also, on a graph, you can, find the horizontal change and the vertical change. So you can find the vertical change, we go down 4, so minus 4, and then the horizontal change, we go to the right 2, so positive 2 on that horizontal X value change. Okay. With a function, we are still doing the same thing. So we are still finding the interval, from the interval negative 5 to 2, what is the average rate of change? So we are starting at negative 5 input and 2 input, but now to find the output, we can't just look at the table or look at the graph. We have to use the equation. So if I input negative 5 for F, what is the output? Well, negative input squared plus 4 times input minus 1. So remember exponents first. So negative 2 squared is 25. So that's minus 25 plus, well, actually, positive 4 times negative 5 would be negative 20. And negative 25 minus 20 minus 1 is negative 46. And then now that we have negative 46, I need to go ahead and find my output for 2. So f of 2 would be negative times input squared plus 4 times input minus 1. Okay, and again, exponents first, guys. Do not multiply these. Please, please, please. Exponents first. So 2 times 2 is 4. Okay, so that's minus 4 plus 4 times 2 is 8 minus 1. Negative 4 plus 8 minus 1 is 3. And then so that is the output here. Now that we have the full points, we can find the change. From negative 46 to 3, we are adding 49. And then from negative 5 to 2, we're adding 7. So 49 divided by 7 gives us an average rate of change of 7. And then lastly, part D, okay, this interval is starting at 1 and ending at 4. So remember, both of those are x values, okay? X is between 1 and 4. So we have x value 1, x value 4. We need to find that y value, okay? So I'm going to find f of 1, and then I need to find f of 4 as well, okay? The order that you actually find these don't matter, but you do need to find both so you can plug in the outputs. So f of 1 is negative 2 to the power 1 plus 4. Negative 1 copy of negative 2 is just negative 2, right? So negative 2 plus 4 is 2. So that is the output. Over here, this is negative 2 to the power of 4 plus 4. Now, here's where it gets tricky, guys. What has the power of 4? Is it 2 or negative 2? It's just the 2, okay? That negative is not in parentheses. So you can almost like imagine this as if it was negative 1 times 2 to the power of 4. Okay? So 2 to the power of 4 is 16. So that's negative 1 times 16, which is negative 16. Negative 16 plus 4 is negative 12. So the output is negative 12. Change from 2 to negative 12 is negative 14. 1 to 4 is positive 3. Negative 14 over 3, can't simplify, so that is the average rate, negative 14 over 3. Okay. All right, and last question. Okay, what was Sally's average speed in kilometers per hour during the first half hour? Okay, during the first half hour. So from the first to the second, what was the average? Okay. Well, here we went up 0.5, right? From 0.5 to 1 is 0.5. For the y value, we went from 7 to 5, so that's a positive 8 change. So 8 divided by 0.5, that is 16. Okay? And then it also asks right there during the last half hour. So from the 5th to the 6th, what was the average rate? Well, from 28 to 36 is 8 as well. And from 2.5 to 3 is also a 0.5 change. So we have 8 divided by 0.5 again. So the last half hour is also 16. Okay. All right. And then for part B, it says, which 2 consecutive stops did Sally's average rate have the lowest speed? Okay. So she's going on this bike trip, right? She's stopping every half hour. And then so basically they're just saying which of these stops has the lowest speed. So we're looking for the smallest average rate of change, okay? The smallest ARC. So now we need to find the rest of them. So from the second to the third is a 0.5 change. And then from 15 to 21 is a positive 6 change. So 6 over 0.5 would be 12. Now I need to compare that, so I need to find the other ones as well. From third to the fourth stop was also 0.5 change. From 21 to 24, that's 3 change only. So 3 over 0.5 gives me 6. And then the last one is from 24 to 28, which is a 4, positive 4 change. Of course, from 2 to 2.5 is 0.5. So here 4 divided by 0.5, we get 8. So which one has the smallest? It would be the pink one from the third to the fourth stop. Something else that you could have done, you didn't really need to do all this math, right? Because the x value is always going in intervals of 0.5, you could have actually just looked and compared the change of the y value. Okay. All right, so that is the review. Don't forget on Friday, okay, Friday the 18th, after school, from 3 to 4, Cabrera help, so that you can get some help if you have any questions on the review or any other questions before the section 1 test. Bye, guys.